I think it's only fitting that we start this celebration with Gary. So, Gary, Air Quality Fuller, if I can use air bunnies, has led the LAQN for most of those 30 years, and he's been a constant driving force in supporting action to clean up London's air. His services to the city were recently recognised by him being recognised as and bestowed with Freedom of the City of London, which was well deserved. He's now one of the UK's clean air quality champions, and he's expanding this cause across the UK and beyond. I've got no idea why I'm looking at my notes, because I know Gary extremely well, and I'd like to invite him to kick off our talks this morning.
Really proud to be standing here in front of all of you. The whole of this seminar series, I think, really brings home to us just all of the things that we've done over the last 30-odd years. We had a big seminar in the summer, and I was asked to open that up and just talk about the sort of 30 years in review. And I'm going to do the same things here now. But, of course, the emphasis here today is very much on the measurement network that we have. So it's 30 years and about 2 months since I walked into this building on the left-hand side, and I was employed to do a temporary job for 2 weeks. Sean, who Ben mentioned earlier, and might be somewhere in the audience, employed me for 2 weeks to start pulling together some of the data from you as local authorities that we were getting at that time. And the whole measurement network, of course, was born, if you like, from those humble beginnings. But what we were trying to do all the way through that was not really just create a measurement network that told us if we were meeting guidelines or limit values for air pollution. It would go beyond yes or no in terms of limit values into telling us why and what next. So over the next just over 15 minutes, I wanted to try to, I think my slides have an auto advance, so this is going to be a bit tricky. I wanted to try to bring out about 10 themes that have emerged from the whole of that time. The first one really is informing the public. We were one of the first organisations to put air pollution information on the internet, and on the left-hand side there's some of our very first web pages. In addition to these web pages, we also used to fax these sheets over to local authorities. As Isabel will remember well, those Friday afternoons when we're shoveling papers and reports into the fax machines. Our web pages have developed quite a long way since that. We began putting dots on maps. We then began drawing maps of air pollution. And today you can find air pollution through a whole plethora of different things, through apps, for instance, like the City Air app, which you can navigate not just an air pollution not just the air pollution in your city, but you can navigate how you walk through it in terms of roads. We've also been working with the Mayor of London, of course, on the air pollution alerts that are issued when air pollution becomes bad in the city. One of the constant companions all of the way through this, I think, is summarised by this slide here, though I should, in the issues of fairness, point out that other polluting diesel vehicles are available. It's not just a question of VW. London's NO2 problem, which is my second theme, is something that's really been with us for the whole of this time. Around about 2000, we were trying to say, would we be meeting the limit values that were set then for 2005? That black line on the graph shows how we're doing over time at our measurement sites, and the straight line tells us the trajectories that we needed to follow for different measurement sites to be in compliance. And you can see over that time period, it was blatantly obvious to us that the rate of improvement was nothing like what was going to achieve the limit values by 2005. We also started drawing our first maps as well. So what was happening? Well, on the left-hand side, you can see one of our very earliest papers. And if you like, the white circles tell us about the nitrogen dioxide we should have had, and the black ones tell us about what we were actually measuring. There was a lot more nitrogen dioxide in London's air than we could certainly account for at that time. We didn't understand why at that time, and it's only really later with the data on the left-hand side from people like the ICCT. Nick Molden's actually up there, and I think you contributed to some of this as well as Dave Carslaw when he was working here. So what we have there on the left-hand side, of course, you'll be familiar with these, is petrol vehicles. On the right-hand side, we have diesel vehicles. The size of the cloud tells us about the NOx that's produced by them. The light cloud in the middle is what they're meant to produce in test environments, and the dark cloud is what they actually produced in reality. So you can see not only were petrol cars less polluting, but they became less polluting. The diesel cars produced more NOx, and progressively over time, they didn't really improve in the way that they should have done. And it's that, really, that has dogged us all the way through. Sometimes I don't feel as though we've been doing science. We've just been trying to understand the things that engineers have hidden inside vehicle exhausts. What was the consequences of that? Well, these are time series of air pollution in different places in London. The top one's Marylebone Road. The red ones are roads in inner London. And then we move through outer London and background sites. And what we can see here is from about 2000 onwards, the situation in London actually deteriorated. You can see that things got a lot worse. And this is something my colleague Louise has been pulling together. We can also see a period that then followed where we kind of hit the doldrums. So there wasn't exactly a lot of progress. The third thing that's been with us all the time is actions and solutions. Principally, or one of these main ones is the low emission zone and ultra low emission zone. And one of our first projects that Ben was heavily involved in was to look at the low emission zone and how well it was working when it was set up in 2008. And this taught us something really, really important about these zones. On the left-hand side, we have concentrations from Marylebone Road and just outside the City of London, the Hackney City border, and then the three further on relate to places in outer London, and they're divided before the zone, about the time it was set up, so this mid and then post. You can see on the left-hand side that setting up the zone didn't really actually make that much difference to the concentrations that we saw in the inner London locations, but what we can see was some improvements in outer London. And the reason for that was that the fleets in inner London were upgraded way beyond our analysis period. So one of the big lessons of this is to look at the effects of something like the ULEZ or the LEZ. You don't look on day one, you look back to see when the fleet actually started changing. The LEZ was, of course, strengthened and changed over time. And we weren't involved in the analysis of the phases that went further on. But some analysis was done, and you can read here the results from the LEZ as it was tightened in 2012. Interestingly, there was no sign, of course, there that there was any problems, if you like, worsening in the areas around the zone. Those of you at the front will be able to see where this paper come from, and it actually came from a university in Australia. And the reason they were able to do this was that they could download our data for their analysis. So that brings me probably to number 4, which is open access to data. And we've always done this all the way through. So back to this third one. I talked about this time period when we were in the doldrums, if you like, when air pollution was pretty flat. It was actually worse than that. I did some analysis with London and Paris with Anna Font, who's moved on from here now. And what we did, if you look at these graphs, so they show concentration along the bottom and then rate of change along the top axis. And you can see that some places were improving a lot. So actually, I can't point to this. Some places were improving a great deal here, and these were the places that had the worst concentrations of nitrogen dioxide. But what we had over this period was a whole set of roads where the situation was actually getting worse. And that was the situation we had in this period, 2010 to 2016. Not only were in the doldrums, but places were getting worse. And if you look at the colours, that was mainly happening at places in outer London. We had a similar picture for PM10, a similar picture for PM2.5. We made a prediction at that time that it would take, at current rates that were then 193 years for London to achieve its NO2 limit values, which is something that then went on to be cited as one of the inspirations for the Mayor to take action with things that the ULEZ. I showed this graph before about air pollution in London as the time series that Louise has prepared of NO2. You can see this period in the doldrums, and then we can see this massive change over here. And this is the instigation of the ULEZ, first in the central area and then in inner London. I apologise for my slides. And what we have here, I mean, I've gone on record as saying this, I think it's probably one of the most dramatic improvements that we've seen in London's air in the whole time we've been operating, and straight away you can see that for yourself. The change is absolutely dramatic. We're seeing a reduction in concentrations, Marylebone Road, at roadside sites, and they are moving to be closer to the background, and that's the situation we find ourselves in now, and it's radically different to what we had before. The next theme really is understanding where PM comes from. When congestion charging started in 2003, it started on February the 17th, 2003. This was followed by some of the worst particle pollution that London had measured since 1996. And what we were able to do at that time was explain why that happened. And we were just developing source apportionment techniques. Well, you can see what's driving this, if you look on the right-hand side, is the concentrations in this pink and blue area. And these are sources that are largely coming from outside London. So even though we had congestion charging, the pollution deteriorated, and we were in a position to be able to explain why that happened. The other thing in understand where it comes from, I think it's been accompanying us now for more than a decade, is the return to solid fuel burning. You can see on the left-hand side how people's homes were through most of the time period from about 1970 to about the turn of the century, with fireplaces blocked up. And then you can see that people unblock them and are fitting many fires. This is leading us to have some PM from wood burning at homes in all of the cities throughout the UK, and it's a problem in London. On the right-hand side, you can see the seasonal behaviour of this, with highest concentrations during the winter times. And also, if you look very carefully, you can see Guy Fawkes Night here, and you can see Christmas here when people invite their relatives round to sit in front of the fire. It's a real problem. But it's only by this research that we're able to pick out this signal. Number 6 will be our research super sites, and Dave will talk about these a bit later on. I called past Marylebone Road earlier on today, and these are measuring so many other things. So one of the things I wanted to draw out here was what happened in this winter that we've just had. This is some data from Anya, from Honor Oak Park, and what we have here in blue is the concentrations of potassium, so fine, tiny particles of potassium produced when you burn wood. What we also have in the yellow is particulate arsenic. And arsenic, of course, is used as a treatment in construction wood, or at least it was. So what we can see here is that people are burning construction wood through winter time in London to keep warm, and that's producing arsenic in our air. Number 7 really is the foundation of London's air pollution models. So many of our models used to be and still are heavily dependent on the measurement data that's collected. These have evolved enormously from being able to just, if you like, join together the dots between measurement sites as we did originally as we were building the network, to being able to draw maps here in black and white to the sophisticated things that we have. But modelling, you'll have to come along in a few weeks to really see about that seminar. Air pollution's all about health. It's all about public health. It's primarily for us not an environmental thing. It's a health thing. Some of the work we've been done all the way through is investigating health impacts. I show up some of the papers here, but one of the first ones we did looked at tiny, tiny particles, so particle number concentrations, that were in London for the first sort of decade of the century. And we found this signal here, which actually caused quite a splash, which was that daily exposure to, if you like, increased levels of particle number concentration was resulting in people, or associated with people going into hospital and also mortality. And so we were one of the first to show that association. Moving on, we've done a lot of work on measurement methods as well, a lot in partnership with our collaborators at the National Physical Laboratory, and I show up some of the papers here. But if you're running a measurement site and you're calibrating it with gases, then the ways in which you do that and the way in which you can be confident about the result comes from the research, or the research that we've done has contributed to that. Similarly, you just have a simple sample system now, maybe where you have just a sample line. On Leon, if he's in the audience, always talks to me about the importance of sampling in environmental measurements. We were able to do work to show that those very simple solutions worked as well as the more expensive solutions that people were being sold. Lastly, what I wanted to talk about was more the future. We're moving towards things like hybrid networks, where we have sensors that work in conjunction with our reference measurement sites to be able to, if you like, produce far more dense data. And we're also doing work with people in a portable sense, and you can see John there walking around the streets of London measuring wood burning. So that's 10 themes that we've drawn out over time, and I think in bringing it to a close, I just wanted to put up the faces of the people that are running the measurement network, and Ick, who will be talking there in a few moments, is featured there. But there's many familiar faces there. But it is really all about partnership, and what we've done here is only been done because when we set out at the start, we set out to work with local government, and it then followed central government, the GLA, and other arms of government, including the Environment Agency. And that's been a main theme of all our work all the way through. We could not have done it otherwise. And finally, Audrey's talking at the end. Audrey and I did was it a World Service or Radio 4 thing? I can't recall. We were in at Broadcasting House being interviewed, and she made the point I should always end a presentation on a positive note. So when it comes to thinking about what our cities might actually be like, I think we can look to places like this and actually use these for inspiration. They're places that exist. And I often think of this little kid in the top right-hand corner who's just thrilled to bits to be sitting there on his space hopper in the middle of a closed school street. So those are parts of the reason we're doing it, to create urban areas that are low carbon, smog-free and healthy cities. So at that point, I will stop. Thank you very much.